The Open Systems Interconnection 7-layer model, or OSI model for short, is a conceptual model that standardizes the way an information systems communication function works. The OSI model partitions communication functions into 7 abstract layers, each of which builds on the layer below it. The OSI model is a valuable abstraction to help us understand the complexity of communicating between system components. It is, however, only an abstraction, and it's important to note that implementations are unlikely to draw the line in precisely the way the model dictates. As an example, TCP/IP, the protocol that powers the internet, only defines 4 layers. At the top is layer 7 of the OSI model. It's called the application layer, and it is where application communicates with the consumer. The most common example being HTTP. Being closest to the end user, it's the layer that exposes value to the consumer. All subsequent layers support the application layer. If you were to use a driving analogy, the application layer is the pedals, steering wheel and other controls of the car the driver interacts with to drive the car. Layer 6 sits below the application layer and is named the presentation layer. It acts as a translation or mapping layer between application-specific formats and the formats mandated by the underlying networks. Protocols such as TLS operate to secure connections between clients and servers, effectively mapping between clear text data and enciphered data. The presentation layer is similar to the transmission of a car, which translates the output from the engine to the turning of drive wheels. Layer 5 supports the presentation layer, called the session layer. It provides the concept of the beginning, middle and end of a conversation between communication partners, establishing the parameters of the discussion. To continue the driving analogy, the session layer is akin to a short-term hire, where you hire a city car for a few hours to make a single trip. You book the car, complete your journey and return the car. Layer 4 sits below the session layer and is called the transport layer, which deals with the actual means of transmitting data across the network. The Internet protocols TCP and UDP are commonly categorized in Layer 4, despite not being developed under the OSI model. A reasonable analogy is the types of vehicles on a road system: cars, lorries and buses, each suited for a different purpose. Layer 3 supports the transport layer, called the network layer, and takes responsibility for providing a means of addressing components of the network and potentially routing data between nodes in the network. The analogy here is the system of postcodes or street addresses for houses in a city, enabling efficient travel or routing between 2 points. Layer 2 serves the network layer. Named the data link layer, it provides node-to-node communication. It also controls flow between the nodes, as well as how to establish links between the nodes. The data link layer is similar in many ways to a motorway or freeway between 2 junctions. The road itself defines the connection between 2 points, and access to the on-ramp controls the flow of traffic. Layer 1 is the lowest layer and supports the data link layer. It provides a physical connection. This is typically the actual wires strung between 2 nodes on the network. To labour the analogy one last time, the physical layer is the materials and construction methodologies of the actual road the cars run on. It's useful to understand this model, as within the IT industry we often talk about Layer 3 network switches or Layer 7 routing, describing equipment that operates at a specific layer. Armed with the city analogy, you can easily translate this into concrete terms.